Alright guys, welcome to Domain and Range Part 2, and we're going to concentrate mostly on range today, but you'll see a few problems where you calculate both domain and range. A couple things really important. Use your graphing calculator to help you try to find the range sometimes. Sometimes when you put the graph in the calculator and you get a visual representation, it's really easy to see what your domain and range actually are. When I give you a problem, also knowing what your domain restrictions are really key to help you understand what your range values can be. So let's look at some examples. Now, in example 1, we want to find the range. Now, again, from our previous slide, we saw that y equals the square root of 2 minus x. We recall that x had to be greater than or equal to 3 because this is a radical, and underneath a square root or a fourth root, we can't have negative values. We can't have the radicand be negative. So just remember that x had to be greater than or equal to 3. Now that's the domain value. And why I use that is part of what I said in the first slide, is that you really have to know what your domain is. So knowing that my x had to be greater than or equal to 3, I had to figure out a starting point. So let's start with 3. Let's make a table of values. So I have just 3, 4, and 5 and seeing what I get. When I plug in 3, I get 0. When I get 5, I get 2. 10 minus 6 is 4. The square root of 4 is 2. And so I'm seeing here that I start at 0, and really I'm going to keep going up to infinity. I just needed to really know where my start is. So let's look at the graph of this. So when I graph this function, I have 3, 0, and 5, 2, and I draw my line. You can see the y values. If you're looking vertically, the y values, there's nothing in the negative. Everything is positive, okay, with exception 0. 0 is not positive or negative, but I'm starting at 0 and I'm going to positive infinity. So that is my range, 0 to infinity, and I use brackets with the 0, okay, because I can include 0. Okay, so that is your first example on how to find range. Now, in our first video, we were talking about a bus trip, and we had this equation y equals 3x, and people were going to go to a playoff game, and we had a possibility of at most 40 people going, or as few as 0 people going on the bus. So when you look at example 2, what is the range y equals 3x from example 1 in the domain range video? In general, a linear equation would have a range of all real numbers. Everything would work. But we have to look at the context of the problem. And the context was for the domain, my domain could only be between people that are 0 and 40, and they had to be integers. You couldn't have 1.5. So 0 to 40, and that had to be integers. Okay? So x was between greater than or equal to 0 or less than or equal to 40. Now what would the range be? I have my start and my end, so I'm actually going to plug each of those values into that function here. I was given y equals 3x. So let's look. So I have the range, y equals 3 times 0, which is 0, and y equals 3 times 40, which is 120. So my range is from 0 to 120. Okay? So since all of these are going to be integers or whole numbers, these would all be whole numbers between 0 and 120, and I conclude both of them. This is a linear equation, a linear function, so I can have those brackets there because nothing is going to be undefined. Now, in example 3, find the function f of x equals 24 over x plus 1 has the domain 1 to 5. Find the range. Okay, so now in this example, I'm telling you that the range is between 1 and 5, and it's very similar to the last example. X is starting at 1 and ending at 5. So why not plug those two values into the function and see what my outputs are? And so that's what I do here. And it looks like I forgot to put 5 there. Let's imagine there's a 5 there and a 1 here. Okay, so here's my function, 24 over 1 plus 1, which is 2, so I get 24 over 2, which is 12. And same thing when I plug 5 in, I get 24 over 6, which is 4. So the range is from 4 to 12, in between. Now, there's no context to this, so I'm assuming that it's going just to be all real numbers between 4 and 12, including them, including 4 and 12. So that's calculating the range, and in the last two examples I've kind of restricted the domain, or even all three of them, we've kind of looked at what is our domain, what are my possible values to get our range values. Now, in example 4, I asked you to find the domain and range, and I put this on here. This is actually pretty quick because I just wanted to give you a different look. And just remember, the domain are all possible x values, and the range are all possible y values. So the domain's quick. -2, -1, 0, 1, and 2. The range is 3, 4, 7, and 12. Notice how if I have any repeat values here, like 4, you don't have to put it twice. You just write it once. Okay, so that's a really quick example of getting your domain and range from a table. Now this last one is an interesting one. I actually graphed it too. This is the cube root of x, and it's asking what is the domain and range of this cube root. Okay, so I have to think first, are there any restrictions in my domain? Okay, and I look at the cube root. I can actually use negatives in a cube root, unlike square roots. Okay, so what I've done here is I think of, I kind of think of reverse. What number cubed would give me this? And I go in reverse so I can think about getting my values. But I use -27, -8, -1, 0, 1, 8, and 27 because when I cube root those, I get a perfect cube out. That's the idea, okay? You know, 27 is 3 by 3 by 3, a perfect cube. And that's the idea when I thought of these values. I can use any other value, but these were the easy ones where I could get some integers here. So, when I set up my domain, there's nothing I can't use here. How do I know that? Look at the graph. If I'm looking at the graph and I plotted these points, okay, I picked perfect cubes for x, and then I solved for y, and then I plotted these points. Okay? Now look, there's no holes, no gaps, nothing, but I'm using x, all the x's, I'm going straight out like this. All the x's into the negative, all positive x's to the right. So my domain is all real numbers, from -infinity to infinity. Now what's the range? The range is going to be the same thing, okay? The range, the y values are going to keep getting smaller here and larger here. They don't stop, there's no asymptotes, you haven't learned that yet. So the domain and range are all real numbers here for both, from -infinity to infinity. So that's our second part of a domain and range, where we saw how to find range, and especially how to find range when we have a restricted domain. But again, when you're talking about range, always look and see what your domain gives you to help you out. If you have any questions or comments, please make them below, or you can email me at nicholas.bennett@dc.gov. Thanks.